Hey there, class. Mr. Pusky here. Hope you're having a good day so far. I'm trying a new way to record lessons. Hopefully this goes well. If you have any issues, please let me know. But we'll see how this goes. So we are continuing with Chapter 6, which is linear inequalities. This is 6.2. The name of the lesson is solving multi-step linear inequalities. An essential question is, how do we solve multi-step linear inequalities? Okay, so solving linear inequalities is like solving linear equations. So this is very similar to if we have 3x plus 2 is equal to 14. First thing we do is subtract 2, right? Subtract 2, and you have 3x equals, what, 12 divided by 3, and then you would get your answer, right? This one's basically the same kind of thing. Let me go back here. It's basically the same thing. Let me just adjust something. Yeah, just getting used to this kind of method here. So yeah, it's basically the same thing, except remember when we multiply or divide by a negative number, you need to flip the inequality symbol. So we're going to write that first in the blank here. So basically the same thing as solving equations, which was chapter 3, which you guys did a really nice job with. So let's fill in the blanks here. When you multiply or divide by a negative number, you must reverse the inequality symbol. Oops, I spelled that wrong. You must reverse the inequality symbol, okay? So basically you flip the sign. Another thing we need to be careful about is we want the variable to be on the left-hand side for when we're graphing, because if it's on the right-hand side, it means the exact opposite. I talked about that in the last video, and so you just want to be careful. When you flip stuff around, you just need to make sure that it's pointing at the same thing it was pointing at before, basically, okay? Well, let's get right into it here. So we have number 1 is is 3x plus 16 is less than negative 8. So my question for you is, if it was equal to negative 8, what would be the first step we would do? We would either divide by 3 or subtract 16. What do you guys think? We are going to subtract 16 from both sides. Yep. These are going to cancel. We're going to get 3x is less than negative 8 minus 16 is negative 24. Okay. What's next? We have 3x versus 3x equals to negative 24. What would you do next? Well, you would divide by 3, so we're going to do the same thing here. Do we need to flip the inequality? We have a negative here. Do we need to flip the inequality, or did we need to flip the inequality? The answer is no. We did not need to flip the inequality, because we have a negative number here, but we did not divide by a negative number. We divided by a positive 3. Only when you multiply or divide by a negative number do you need to flip the inequality, okay? So now we're going to have, the 3's are going to cancel. We're going to get x is less than negative 24 divided by 3 is going to be negative 8. And that's our final answer. X is less than negative 8. One more thing I want to talk about that I didn't talk about in the last video is an easy way to graph inequalities, linear inequalities like this. See, this will make a thing. No, it's not going to work. Oh, well. So the way I like to graph these is I like to put 0 in the middle, just to kind of have an origin or kind of have a reference point. I'm going to put negative 8 somewhere to the left of it, because negative numbers are to the left, right? And then I'm going to put an open circle. It's not equal to a negative 8, and I'm just going to draw an arrow pointing to the left. So when you draw your graphs, you do not need to write out all the numbers like negative 1, negative 2, and all that stuff, okay? All you have to do is put 0 and then put another number to the left or right, depending on where it is. If it was x is greater than or equal to 4, we would put 4 over here, filled in circle, and we would go to the right, okay? So that's kind of a shortcut to help you with this stuff. Let's see how this erases. Let's see if this erases. Oh, that's not too bad. So yeah, so that's kind of a shortcut for graphing linear inequalities, or just graphing inequalities instead of graphing with all the different, like going 1, 2, 3, and then 4. You don't need to list all the numbers. I don't care if you list all the numbers, okay? All right, first one's done. Number 2, we have 26 is greater than or equal to negative 4m minus 10. Okay, so we're solving for m, which means we need to get m alone and get the numbers to the other side. So if we had 26 equals negative 4m minus 10, what would be the first step we're going to do? Well, we're going to add 10 to both sides. We want to get the negative 4m by itself. So then we're going to get 36 is greater than or equal to negative 4m. That's 26 plus 10 is 36. Okay, what's next? Well, we need to get rid of that negative 4 times m, so we're going to divide by negative 4. We're going to divide by negative 4, so we're going to get 36 divided by negative 4 is negative 9. Now, what's the sign going to be? Is it still going to be greater than or equal to, or is it going to be less than or equal to? And how do you know? Well, it's actually going to be less than or equal to, but why? We divided by a negative number, so we need to flip the inequality. It's going to be negative 9 is less than or equal to m. And another thing, there's another problem with this now. We have our answer, but what's wrong with it? We want the variable. We want the variable on the left. Okay? Is the variable on the left right now or no? It is not. So I'm just going to draw some arrows. We're going to just flip these around. And so I'm going to write m. I'm going to write negative 9. Now, when I flip it around, it was pointing at the negative 9, so it still needs to point at the negative 9, like this. It's going to become not less than or equal to. It's going to become greater than or equal to. Shoot, I can't draw. Greater than or equal to negative 9. There's our answer. Or you could say that it was eating the m, so it needs to continue to eat the m when it goes the other way. Okay, and there's our answer. It's actually a pretty short lesson today, so let's get into number 3 now. The next ones are going to be a little bit more tricky, but still the same procedure follows. Let's do blue. Okay, we have 5 times the quantity of x minus 3 is greater than negative 6x plus 12. So imagine this was like an equal sign. If that was an equal sign, what would be the first step? Remember, we're solving equations. What was the first step? We need to simplify, which means we need to distribute. This is kind of a throwback. Don't write this down for now. Distribute and combine like terms, right? Distribute and combine like terms is the first step when we're solving equations. Okay? So, anything to distribute here, first of all? Anything to distribute here? Oops. I'll get the hang of this, I promise. There is something to distribute. You need to distribute the 5 to the x and 5 to the negative 3. So 5 times x is 5x. 5 times negative 3 is, negative 15. It's greater than negative 6x plus 12. All right, anything else to distribute? No. Any like terms to combine? No. Like terms would be if we had like 7x minus 5x. These would be like terms, and this would not be a like term, right? Same variable, same exponent. So it is not, there are no like terms. So now we need to move stuff around. There are lots of ways, there's basically 2 different ways you could solve this, okay? There are 4 different things you can do first. You could subtract 5x to move 5x to the other side. You could add 15 to both sides. And on the other side, you could also add 6x, and you could subtract 12, okay? But basically, you don't want to do it all willy-nilly. You want to be kind of methodical about it. When you're solving, you want to get all the x's to one side, where you have something like 3x, and you want to get all the numbers or the constants to the other side equals 27, something like that, right? So just think about what you're trying to do, and then you can solve it any way you want, but just make sure that you try to get the x's on one side and all the constants to the other side. So I like to move, I like to end up with positive x's, so I'm going to add 6x to both sides here. To kind of cancel these 6x's here, 5x plus 6x is 11x. Minus 15 is greater than 12. Okay? And now we need to get, we have the x's all together. Now we need to get all the constants together. So how do I move the negative 15 to the other side? Well, I'm going to add 15. That's the opposite of subtracting 15. These are going to cancel. We're going to get 11x is greater than 27. 12 plus 15 is 27. And now we have the x's on one side, the constants on the other side, but now we need to get x all by itself. So how do we undo multiplying by 11? We're going to divide by 11 on both sides. X is going to be greater than. Do we need to flip the inequality or no? Did we divide by a negative number down here? We did not. Multiply or divide by a negative number. We did not. Then 27, does that divide by 11 or not? 11 is actually a prime number, and it does not. 27 does not divide by 11. So our final answer is going to be x is greater than 27 over 11. All right, good job. Let's take a look at number 4 now. Last one for the day. It's kind of a short lesson because it's kind of just a little bit of an extension of solving equations, basically. All right. So negative 3x plus 6 is less than or equal to negative times the quantity of 2x plus 10. So like we're solving equations, if it was equal to, right, we're solving like it's equal to, even though we have a inequality symbol. Anything to distribute here. First thing is to distribute. This is like we have a floating negative in front of this. It's like there's a negative 1 here, which we're going to just distribute this negative to the 2x and the negative to the 10. So I'm just going to write the rest of the problem. Negative 3x plus 6 is less than or equal to. What is negative times 2x? Well, that's going to be negative 2x, or negative 1 times 2x, that is. Negative times positive 10 is negative 10, or negative 1 times positive 10 is negative 10. All right, sounds good. And again, anything else to distribute? No. Any like terms to combine? No. If we had like minus 4 over here, these would be like terms. We would combine them, right? But we do not have any like terms. So now we need to get all the x's to one side and all the constants to the other side. So I want to move the x's first. You could either add 3x to both sides, or you could add 2x to both sides. I'm going to add 2x to both sides to keep the variable on the left. You want the variables to be positive, and you want to keep them on the left if possible. In this case, we're not going to be able to do both, but it'll be a good step to do that. So we have negative 3x plus 2x is negative x, plus 6 is less than or equal to negative 10. All right, all the x's are together, so how do we get all the constants together? Well, we're going to subtract 6 from both sides. So we get negative x is less than or equal to negative 10 minus 6 is negative 16. All right, last step is to get rid of that negative in front of the x. So we can either multiply or divide by negative 1. I like to divide by negative 1 usually. But you can multiply by negative 1. And what do we need to do? We divide by a negative, so we need to flip the sign from less than or equal to greater than or equal to. And negative 16 divided by negative 1 is positive 16. And there's our answer. It's kind of hard to pinch and going in and out here. And that's all we have for today. So thank you for watching. Have a great day, and we will talk soon.